In this video, I'm going to show you how to convert between grams and moles. Molar mass is the mass of 1 mole of a substance. So the molar mass of lithium is 6.94 grams per mole. So that's the number of grams, 6.94 grams in 1 mole per mole. That means 6.02 times 10 to the 23rd atoms of lithium have a mass of 6.94 grams because this is 1 mole. So if you have 1 mole of atoms, or 6.02 times 10 to the 23rd atoms of lithium, then you would have 6.94 grams. In order to find the molar mass, you look at the periodic table. So this number right at the bottom is the molar mass. That means that for beryllium, 1 mole of beryllium, or 6.02 times 10 to the 23rd atoms of beryllium, have a mass of about 9.01 grams. So 9.01 grams per mole is the molar mass of beryllium. So let's try a problem. How many grams are in 0.02 moles of magnesium fluoride? So our question is how many grams, that's our unknown, are in 0.02 moles of magnesium fluoride. That's our given. So we're converting from moles into grams. Well, in order to do moles into grams, we need an equivalence factor that connects moles and grams, which is molar mass. So our first step is to figure out the molar mass of magnesium fluoride. So we look back at the periodic table, and we see that magnesium has a mass of about 24.31 grams per mole, and fluorine has a mass of 19 grams per mole. And I'm just going to round to the hundredths place. So we need to find the molar mass. So we take the mass of magnesium, and we only have 1 magnesium, so we only write it once. And then we have 2 fluorines, so we multiply the mass of fluorine times 2. So when we add these together, we get a mass of 62.31 grams per mole. So this is the molar mass of magnesium fluoride. So if we had 1 mole of magnesium fluoride, that would equal 62.31 grams. But we don't have 1 mole, we have 0.02 moles. So we're going to expect a number to be a lot smaller than 62.31 because that's the number of grams for 1 mole. So now we're ready to solve for the number of grams. So we start with our given, which is 0.02 moles of magnesium fluoride. And we draw our multiplication sign in a line. Now we need to get rid of moles, so moles goes on bottom. We need to cancel out moles, and we're converting into grams. Grams is our unknown, so grams goes on top. Well, we know that 1 mole of magnesium fluoride equals 62.31 grams of magnesium fluoride. So both of these are just applying to magnesium. So we put this in our calculator. We do 0.02 times 62.31, and we end up with 1.25 grams of magnesium fluoride. Notice grams is what's left over, so grams magnesium fluoride is our unit at the end. How many moles are in 68 grams of copper nitrate? So this time our unknown is moles, and we are given 68 grams of cobalt 4 nitrate. So our first step is to find the molar mass of cobalt 4 nitrate. So cobalt is right here. And we have nitrogen and we have oxygen. So let's add those together and find the molar mass. We have 1 cobalt, so we write 58.93, but then we have 4 nitrogens, so we'll have 4 times 14.01, and we have 4 times 3, so 12 oxygens. So we'll add all these together, and we get 306.97 grams per mole. So if we had 1 mole of cobalt 4 nitrate, we would have 306.97 grams. So if we had 2 moles, we would have double that, about 612 or 14 grams. But we don't. We have 68 grams, and we're converting into moles. So notice 68 is less than 306.97, so we would expect to have less than 1 mole of cobalt 4 nitrate. So, as per usual, we start with our given, 68 grams in this case, of cobalt 4 nitrate. And we are trying to get rid of grams, so grams need to cancel. So that goes on bottom. That's cobalt 4 nitrate again. And we are converting into moles, so moles goes on top. And we already calculated what 1 mole is equal to, so if we have 1 mole of cobalt 4 nitrate, we have 306.97 grams. So notice the 306.97 is connected to grams because that is the molar mass. That is the mass in 1 mole. So we're going to do 68 times 1, which is just 68, divided by 306.97, and we get 0.22, and our unit is moles of cobalt 4 nitrate.